All right, anyway, let's go ahead and continue with segment proofs. So we did some of the algebraic proofs, just, using the properties that we have. So we're gonna have some different properties. And again, these are the things that we covered last week and the week before, or actually, well, there was no week before. This week and last week is what I should have said. So again, if you have the notes, take a picture, write them down in a separate notebook or something, but make sure you have something that has these on them, because you will need to remember what those are. Without these, without the information that goes with it, I don't think there's really much you can do. Anyway, let's go ahead and go with what we're given. So again, anytime we have a given, we must assume that it's true. So E is the midpoint of DF. So there's our line segment DF, and E is right in the middle. And there's a couple of things that we could get from that. So we want to prove that 2 times DE is equal. So DE is just this short segment right here. And if we double that, it's going to be the same as D to F, which is the entire line segment. All right, so let's see, E is the midpoint of DF. Okay, so that's given. And again, anytime something is given, we can assume that it's true. Because sometimes, again, diagrams are not always accurate. But any statement that we're told is given, we have to assume that it's true. All right, so DE, excuse me. So line segment DE is the same as EF, and that is the definition of a midpoint, right? A midpoint is directly in the middle of those two parts. And if it's directly in the middle, then those two segments should be the same size. All right, but again, we're trying to make it so that we get 2 DE. So to go from step 2 to step 3 for reason number 3. So let's see what they did here. So they added, right? So we start off with DE and EF is over here. So it looks like they added a second DE. So if we double the length of DE, right, that would be the same as just going over it twice. Since I have DE on the same side, if I combine them, that would just make it 2 DE by combining them. Then from here, we would have DE and EF, which so far there's not anything we can do. Those are not like terms. So in order to be a like term, remember, it has to have the same variable, same letters. And now let's see what's going on from 4 to 5, so we can get reason number 5. And it looks like, what did they do? All right, so they used segment addition postulate. So DE, so they minus DE from both sides. And that would be DF. So DE, oh, this is not really, they're just saying that DE, so this one here, to EF, right? If you add them, they should come out to be the whole thing, DF. So they're taking the element from this one, they're taking the 2 DE, and since here we have DE plus EF and DE plus EF, so again, if you have two things equal to each other, you can just set them equal to each other. So again, we both know that, let me go ahead and just circle that so you can see it a little bit better. So again, DE, EF, DE, EF. So they have 2 of these, one from here and one from here, and they just took those out and set them equal to each other. And again, that's transitive property, because if we know this is equal to that and that is equal to DF, then we know that 2DE is equal to DF. And again, some of these might be a little bit tough. I wish I could do more of these. But this is, again, review. Mr. Moreau, or whoever your last geometry teacher was, covered this a little bit, and I'm just kind of going over it again in the short time that I'm given. Go ahead and go down here. All right, so we have another set of figures over here. We have K, LMN. All right, so given that KL, so line segment KL, is the same as LN. So this one and this one are the same. LM and LN, so LM, this one and this one are the same. So you could probably say all three of these line segments are the same size. And L is the midpoint of KM. So now we know pretty much that this is the same as that. So let's see how the statements go. So they already have the statements here. You would only need to fill this part in. So how did they get from 1 to 2? And again, don't forget to put your given as the first reason, because how it's given to you, you don't have any choice on that. You just have to kind of work with whatever you're given. All right, so let's look at what we have going on here. So KL equals LN. LM equals LN. So it looks like they just took off the line segment thing, and they're turning it into something that looks like they could do math with it. Because if you have a congruent symbol or segment, generally you can't really do math stuff with it, okay? So you in this case, we had to take them off. And we already know that they're equal in length. So rather than saying they're congruent, let's go ahead and set them equal to each other. And that is the definition of congruence, because we know they are the same size. And we kind of have the same thing here. So KL equals LN. LM equals LN. So there's two LNs. An LN here and an LN there. So again, there's two things. So what we're going to do is, since we know they're both equal to LN, we're going to take out the LN and we're going to put those two other things together. So KL and LM are going to be set equal to each other. Since we know L is the midpoint of KM, that is the definition of a midpoint. So now we have proven that L is the midpoint of KM. And again, yeah, Mr. Moreau was saying that most of the students he had trouble with this stuff here. I'm trying to think if there's a better way I can do this. I'm not sure. I'll have to think about that. Maybe on Monday or so, if we continue this, we'll have to kind of go over it again. And I could use the Promethean program, but I don't think that would really help out. I mean, here you can see everything, so it's a lot easier to copy it all down and write it down for your notes. And even though, again, I think it would be a lot better to go over these step by step, you know, working them out. Yeah, that would take a while. How much time do we have? Okay. So anyway, let's go ahead and do this part. So given PQ is congruent to TQ. So PQ, TQ. So we know this one and this one are equal in length. UQ and, excuse me, QS. So these two are also equal in length. What we want is to prove that PS, so this whole thing here, is the same as TU. So again, there's our given, and it's written just as it would be if we were writing a statement about the congruency. So we still have our line segment marker and our congruence sign. So we're going to take those off so that we can do some more math stuff with them. And since it's telling us they are congruent, that is the definition of congruent, right? So we know they're the same. So from PQ, so let's see, looks like we have two things going on here. Well, if we have TQ, right, TQ, that would mean that we could also plug in OS and PS. So OS, or sorry, QS, QS and PS. So that whole segment. So if I have two of the shorter segments, I can add them up to the longer segment. So TQ and QU, TQ, QU. So again, we're talking about this whole segment here is equal to TU. And again, that's the segment addition postulate that says the total length of a segment is all of the smaller segments added together. All right, so now what we can do is we have two of them compared to the same thing. So since this is a, let's see which one is the same. Substitution, so they substituted something out. So PQ equals TQ. And again, that was one of our givens, PQ equals TQ. So what we're gonna do is we're gonna take one of those out and replace it with PS. So substitute that in. And we also have a second one. So this is a similar one, that PS and TU are the same thing. So PS and TU. So we're trying to prove that. And if I take both of those statements together, well, again, PS and TU are the same thing because you see how they were able to put them equal to each other, TQ, QS, TQ, QS. So by transitive property, I would know that this and this would be the same thing because they're both equal to TQ plus QS. And using transitive property, just set them equal to each other again. And that's a very common thing that happens with these proofs, is that you kind of prove two things are the same thing and then set them equal to each other. Now we got to put it back into something that looks like a geometry statement. So we put this line segment on there. So now we know that PS and TU are now the same length. So we mark them as congruent. So line segment PS is congruent to line segment TU. And again, that's the definition of congruence. Yeah, you are going to need those, the study guides and stuff that go with it. So if you turn those in, which I'm not saying you shouldn't turn them in, but you should make yourself a copy of all of the reasons, okay? Anything that says definition or postulate or property, you need to have that one marked down somewhere. And there's some other things you can do too, you know, mark a, take a picture or screenshot of something. I'm gonna go ahead and move on down so we can get to number 4. And again, looks like there's about 12 of them. So we're about a third of the way through. And we got about 30 minutes left over. So hopefully we can get done with this and get ready in time for second hour. All right, giving you a minute to start writing these down because I know this is, especially with these ones, there's a lot of writing, right? So we have to write all that, and they're fairly long sentences. Ugh. So all right. And let's go ahead and get ready to move on with this. So again, I know there's a couple of leaps, like for instance, you know, you have to go from here to there to there to there. But at least in this one here, they give you what's going on, and all you have to do is identify what's going on. Later on down the line, we might have to do this part ourselves. So here I have K, and it's telling us that K is the midpoint of JL. M is the midpoint of LN. So we know that M and K are the midpoints of their own line segments. What we want to do is prove that KL is the same as LM. So it tells us that they're the midpoints, right? K is the midpoint of JL, M is the midpoint of LN. So those are the givens, and it's always helpful to start with the givens, right? So start with the givens, and anytime something is given, it's always assumed to be true. All right, so JK, so from here to here, is equal to LM. LM is equal to LN. So this whole thing, so these two segments, this one and this one are equal. This one and this one are equal because we know they're a midpoint, right? Because if K and M are midpoints, then that means this segment of each one are going to be the same. We also know that JK, so here we know that this little segment is the same as this one, MN. That's a given, so we know that's true. If we substitute it, so MN equals KL, MN equals KL, because we know they're each of the midpoints, so we know they have to be congruent. LM and MN. So if we use the substitution property, we know that JK and LM are the same thing, so MN and JK. Because again, that's one of the other givens that we have, so we're going to substitute that out. So we have K, and we have MN on both sides. See MN here and MN there. So using our transitive property, since both of them are equal to MN, we would know that KL and LM are the same, right? So again, if this was you, and you know how tall you are, and you have a friend who is the same height, and you're playing basketball, and your friend explains that the person you've never met is the same height as him, then you know that the person you haven't met is the same height as you. And that would be the transitive property. So something, and again, it follows that logic that we've been working on, like on yesterday, was it? No, Tuesday. Yesterday and Tuesday we were working on like going from one step to the next step. And that's really what a lot of geometry is trying to go from one step to the next step and explaining how we did that. So anyway, so that's transitive property. We also know that KL and LM are the same. So if, oh, sorry. No. All they did was switch it. So LM here and KL. So they just switched the sides, switched the order. And switching the order kind of, well, I don't know if they really needed to do that. But now we know that KL and LM, so this part and this part are the same size. So we write it back into segment notation. So we know that they are congruent, right? So definition of congruent is that they are the same size. Okay, moving on to number 5. Let's see if I can go down there. And I gave you a few minutes to write that first one. So I'm hoping everyone's done with that first one because we're moving on to number 5. I'm gonna grab a water really quick and you can get number 6 while we wait, while you wait. So like I said, I'm not feeling too good today. Should be over soon though, I'm guessing. It seems like it's already getting better. But you gotta stay hydrated. All right, let's go ahead and move on. All right, so what do we have here? So given x, y, and uv are congruent. So again, think about that. We know that this part is the same as that part. YZ is the same as TU. So already, since we already know that this segment and that segment are the same, and this segment and that segment are the same, we already know that these two things should be the same size. That's just segment addition postulate, right? So if we add them together, XZ and TV should be the same also. Now we know that one would be, this one is a pretty easy one to kind of point that out with, because we know it, but we have to prove how we know it, how we're sure, okay? So it's like, well, a lot of times people want proof of something, you know, even if it's something that's not really that hard. Like, can you do a kickflip on a skateboard? Okay, that's not that hard. But then some people, they just want to see it. So that's kind of what's going on here. We already kind of know it, and this was a very simple one, but how do we know it? How do we prove it? All right, so here's, excuse me, start with our givens. Right, we just rewrite this thing here, write all of that here. And then take these off, which when you do that, that's always going to be definition of congruence, whether you're taking off the line segment markers or in the congruent markers. It's just definition of congruence. We already know that they are congruent, so they equal each other in the number of, well, in this case, we're talking about length. I don't know what they're, we don't have any units, so we don't know if this is inches or centimeters or anything like that. But again, that's just definition of congruence. Anytime you take those things off or put them on. Okay, so let's go ahead and see what's going on between here and here. So it looks like we start off with XY. They put in a YZ right here. They put that in. And then they have an XZ here, XZ. And then over here we have TU plus UV equals TV. So let's look at what, so from here to here, sometimes there's not always like a step. So let's look at what the diagram says. XY plus YZ. So they're saying the big segment plus the little segment equals from X to Z. And then TU, so the second statement here is just saying TU and UV. If we add them together, then we get the length of TV. All right, and they're just telling you that this is segment addition postulate. That's all they're saying, that it's just a very common basic property. Now, since we wrote the whole thing out, we have XY equals to UV. So UV right here. So UV is this long segment, and XY here. TU, the short segment, is equal to this other one's short segment. So what they're doing is they're going to substitute them with each other. So let's see which one they are going to use. And I'm guessing that they are going to use the UV and YZ. So look here, let me write it, let me mark it on the screen. Oopsie. So again, if you have two things, UV, YZ, UV, YZ. So that's what it takes. It takes a really keen eye to spot that those two things are the same. So we have a UV here, UV there, plus YZ here, plus YZ there. So we know they are the same. If they are set to the same thing, then see how we take XZ here and TV here. So again, that's transitive property. We know that these two things are equal to the same thing. And if they're equal to the same thing, then that must mean they must be equal too. Now we just put the little markers on top and write down definition of congruence, because again, if something says that they are equal in length, then that means they are also congruent. So when you say something's equal, you're talking like specifically, like, you know, if I had a ruler, or actually, you know, I have a really good example right here. So if I had, say, two pencils, right? They are congruent. Well, maybe not. That one, I wrote a little bit with this one, so it's a little bit sharper, so it's like a little bit longer, but you get the idea. I have two pencils, and we already know they are 3.5 inches, or I'm just gonna say they're 3.5 inches. I don't know if they're actually that. But since we know they're congruent, we know that their measures would be the same. And I just made up the example of 3.5 inches. So if we know they're both 3.5 inches, yeah, that we know they're the same. That's all definition of congruence is. So each of these is not really that tough on their own, one by one, and that's the way you have to take it. You have to take it one by one, because if you start, you know, looking at the whole thing, you know, it's sort of like cleaning your room. You know, maybe if you need to clean your room, you look at it and you're like, man, there's so much mess here. I don't think I'm ever going to clean this up. Well, just start with one corner and kind of work your way around and just keep going until the whole thing is done, right? Just take it one piece at a time. All right, so let's go ahead and move on to the next one. Number 6. So given YW, so YW is here, this little tiny segment here. Now be careful because sometimes these diagrams, you know, it might show that it looks little, or maybe that it looks like one is longer than the other, like to Z is longer than to W. We always have to go with the statements, which looks like exactly what I was just thinking right here. YW equals YZ. And it looks like the copy machine or whatever kind of hiccuped right there because you can see that there's kind of a line that goes right through there. So sometimes that happens too. Sometimes it's a machine that does that. And we also are given the fact that XY, so that's this here, is the same as VY. So we have 2 long segments that are congruent and 2 short segments that are congruent. What we got to do is prove XZ, so from here to here, and V to W, from there to there, are also the same. So we want to make sure that we know that these 2 lines are congruent. So start with our givens, right? So write all of that stuff, and that's what we're given. So we know that those are true, even if the picture does look a little bit off. Now take off those markers, the segment markers, and replace them, replace the congruent ones with equals. That way we can do math stuff with it. Because you can't really use math stuff if you're using congruency. All right, so segment addition postulate. So XY and YZ would be equal to, well, we know that these 2 are equal to each other. Wait, hold on. Oh, we're working on number 3 now. So XY, YZ would equal XZ. So that's segment addition postulate. If we add this one to that one, we would get the distance from X to Z. So VY, YW is equal to XZ. Now, what we're doing is we're saying this segment here, these 2 put together, is the same as that one because we're substituting it. Because we already know these the 2 short sides and the 2 long sides are already congruent. So if we were to take one, like from VY to YW, and say that it was the same as XZ, well, that would be just substitution property because, again, we already kind of know the pieces that make them up will make them the same. All right, now let's go ahead and put this together. So we would also be able to say that it would be the same as VW. So XZ and VW would be the same. And again, we set them equal to the same thing. In this case here, they set them equal to, let me get that pencil thing out again. They set them equal to VY and YW, VY and YW. So try to set things to the same thing. So now that we know XZ, so XZ is this one, VY would be that one, and that would be transitive property because we can take this one and set those 2 equal to each other. Because we already know that these 2 things are equal to this set. So just set them equal to each other. That's transitive property. Put the little markers on them, definition of congruence, and we are done. Okay, now, since we're done with that, I'm gonna go ahead and go on to the next one. And we should be almost done with this. Let's see, we only got like 15 more minutes or so. Oh gosh. Oof. Looks like we got a triangle here. Oh man. All right. So it looks like this one doesn't have a whole lot of stuff to write. So we should be done with this one pretty quick. You know what? I just now thought of this. I'm going to zoom in just a little bit more so that you can get a bit of a bigger picture of it. All right, so let's get this done with. Let's see. E is the midpoint of AC. So this and this are the same. And I know it's a lot of stuff to keep track of sometimes. Okay, I know, like, well, actually, you could probably write some other stuff here, you know, like put a mark here and a mark here that tells you that those two things would be the same. Because if we know E is the midpoint, right, the midpoint is right in the middle, that would mean this segment is the same as that one. We are also given another piece of information. DE is the same as EC. So see how this one here has one mark? Well, we know that this DE segment is also the same. So we kind of know that these three things should be the same in length. So what we're trying to do is prove DE is the same as AE. And again, just looking at this diagram, you could probably tell they got to be equal, right? But again, we know that these two are equal and we know these two are equal. So it's just a matter of using the transitive property to get there. And again, I know some of these look pretty complicated, but well, if you just kind of take it to one step at a time, work it through, you know, in chunks, it shouldn't be that big of a deal. So E is the midpoint of AC. That was a given. And we know that there's a definition of a midpoint. That's pretty much what I was just talking about, right? So AE and EC, we mark those two so that they are the same. And we would just say definition of midpoint, because that's what a midpoint does. It's right in the middle. DE and EC is also a given. DE, EC. That was one of the other givens that they gave us. Just use transitive property. AE, oopsie, AE and DE would be the same. You have the little marks on top, so just take those off, switch sides, and you got symmetric property. So again, like AE was the first thing here, switch it so that AE is on that side, DE is on this side, because they want you to make it look like this. So it's just a simple matter of switching the sides. Once they switch the sides using symmetric property, that's it. And again, see that one? It was pretty easy. Pretty easy. All right, I'm gonna go ahead and move down to the next one. If we need to, we can probably save a little bit of time and go back through some of these. Anyway, I'm going down, and I'm gonna zoom out just so that way you can see this next one here too. So, and you can see a little bit of the last one as well. So given RS is 1/2 of RT. So that's what they're telling us, RS right here, that's half of the whole segment. What we want to do now is prove that S is the midpoint of RT. So let's start with our given. And let's get rid of this fraction, right? So if you have a fraction, it always makes things more difficult than it needs to be. So what we're gonna do is we're gonna multiply both sides by 2. Because if you take half and times it by 2, you just get 1. So we have 1 RT, or just RT, we don't need the 1. But we also have 2 RS. So looking at what it says here, twice this length should be the whole thing from R to T. And that's exactly what they're saying. They're saying that the RS and ST, put them together, that would make RT. That's the segment addition postulate. Add those two things together, and then you get the whole thing. Now, try to substitute it again. They're trying to get two things that would be the same overall. So it looks like they have RT here, RT here. So what they're going to do is they're going to take what is equal to RT, which in this case 2RS, and they're going to move it down here. RS and ST, we have another set because again, that's also compared to RT. Since both of them are compared and equal to RT, we can set them equal to each other. And then let's see, subtract. If we subtract 1 RS, well, we have 1 less RS here. RS, and that's gone, so we subtract RS from both sides. Now we know that RS and ST are the same, RS, ST. Since we know they are the same, that is the definition of a midpoint. So therefore we prove that S is the midpoint of RT. All right, down to the last one. In fact, I don't need to really scroll down all that much. You could probably see the whole thing here. One thing that might also help is to put the prove part as the last step. And in fact, with this one, you could probably, well, with this one and probably some of the other ones, you could probably work backwards as well, right? Because if we have these things here, we know we're gonna have to take them off at some point, and that's already like, we only need to cover 3 steps. But anyway, let's go ahead and keep working on these the way we should, you know, from beginning to end. So M is the midpoint of LN. So from L to N, that's the midpoint. N, so we have a second given, and that is N is the midpoint of MO. So that's the midpoint here. And again, you could probably just look at this and kind of tell what's going to be the same. You could probably even say that all 3 of these segments are the same. But what we're looking for specifically is LM and NO should be congruent. So M is the midpoint of LN. That's one of our givens. That since we know, again, from here, LM to MN, that is the definition of a midpoint. Definition of midpoint says that if you put a mark right in the middle, that's going to split both of those segments directly in half. So we know those 2 are the same. N is the midpoint of MO, so that is another given. So here it is written given, but we would have to write that in. So it's like, okay, well, we have one given, what's the other given? Oh, it's right there. See, just fill it in like that, pretty easy. MN equals NO. MN equals MO. Because again, we were told that N is the midpoint of MO. That's the definition of a midpoint. Transitive property, since we know that, this is the same as that, LM should be the same as NO. So that's just transitive property. Take the little marks off and you're done. That was it. Okay, so again, I know that was kind of a, you know, it was kind of a rundown. And I also know that proofs are one of those things that a lot of students have trouble with. And I wish I could help, but unfortunately we won't be able to work together immediately. And that's usually going to cause a couple of problems. But just try your best. Just try to get as much as you can. Remember, another thing about this too is that there is another homework assignment here. All right, I hope everyone got this down because I'm going to scroll down a little bit. So you only have that homework. Oh no, it looks like there was one more page. Oops. So only go up to homework number 8. There is a little bit more. There's a little bit more with angles and all that stuff, and that would be homework 9. But we won't have time to cover that this week. And that I think is the last one because from here it starts talking about the Unit 2 test. So that's usually an indication that it's the end of that lesson. All right, so I know we stopped about here, and this is the last page that we should have covered. We probably won't have the time. Wait, no, was that it? No, okay, so yeah. This is something different. Some of the problems look familiar, like this one kind of looked familiar, but it's a different problem. All right, so let's start getting ready for second hour. Start writing that down. I already talked about the grades. I already talked about attendance. So everybody should be really good on that, okay? I know that some people haven't gotten the packets that I wrote your names down. I'm gonna try to find a way to get you the packets somehow. The only thing is that we only mail them out every once in a while. So you probably won't get another mail drop until next week. So if you're missing any of the packets, write me an email, not to chat, because as soon as I close this window, the Zoom out, it's gone, okay? So write me an email on any of the chapters you're missing, and I'll try to get it out to you. But because it's summer school, we only have like a very bare minimum of staff and teachers. So on Tuesday or so, I had to run some papers out to a student. He's like, I'm waiting outside. Can I get the papers? And I'm like, is anybody else out there? They're like, no. And I had to go run out there myself and go check on what was doing. I can't really leave it. Or maybe I can, actually. I've seen some of those in there. I'll try to find one of those big envelopes and put it on the on that cart. Okay, because I'm pretty sure there's not going to be anybody out front. There's usually somebody there, but like I said, we're kind of short on people, so I wouldn't count on somebody being out there. And I did have a student call me saying that nobody's helping them, so I had to leave my room and go all the way to the front of the building and help them out. All right, so I'm gonna go ahead and move down a little bit. We'll go ahead and call it a day from here. So I know this is not a whole lot of time to get all of this down. This will be on the video, which I'm going to be posting very soon. And again, only go up to homework number 8, even though there's more stuff. We're only going to go to number 8. I don't want to cover this on Monday, because I know once we're done on Monday, I'm going to get a whole bunch of students saying, oh, I need more time to finish it. No, you should be done with it by this weekend and turn it in on Monday. So by Monday, I should have a whole bunch of more packets of chapter 2. Okay, but if you can't come by, mail is just terrible right now. The mail is just terrible. So best thing to do is to just come by the building. And I'll see if I can get some big envelopes, and I'll see if I can pack them in there and stuff like that, because I do have some students saying that they didn't, like they opened their packets and they're missing one of them. So you should have gotten packet 1, 2, and then the pretest in the first packet. This one coming up should have 3 and 4. So you should have units 1 through 4 and the pretest. The last week will probably have the post-test. So that's it for my announcements. Again, we got second hour coming up in the next minute or so. So I'm gonna have to close this out.